Okay, as we were saying, we got the u equals 4, u equals -6, or u equals 4. So I had to go back to what I set u equal to, 1 over x minus 3. And instead of saying u equals -6, we say 1 over x minus 3 equals -6. So I multiplied x minus 3 times -6. And we get 1 equals -6x plus 18. So then subtract 18 from 1, -17 equals -6x. X is 17/6. That's one answer. The other answer, remember u was equal to 4. So I'll say, okay, I don't care what u is. I want what x is. So I'm going to say u equals, 1 over x minus 3 equals 4. We multiply x minus 3 times 4, and then we distribute, and we get 4x minus 12. 4x minus 12. I add 12 to the other side. I get 13. 13 equals 4x. Divide by 4. And you get x equals 13/4. I know that was a little sloppy, guys. But I think you have the idea from there. Hopefully you're doing them along with me. 17/6 and 13/4. Okay? Let's try one more. It almost is screaming quadratic-like, isn't it? I have this thing squared minus 2 times that same thing equals 3. Okay? So obviously I'm going to use something else other than u, because this is the u. They're using u. I'm just going to say y. Y equals u squared plus 2u. So everywhere there's a u squared plus 2u, I'm going to substitute y. So I have y squared minus 2y minus 3 equals 0. I'll factor that. I can see that that's going to factor nicely. Y minus 3 and y minus 1. So I get that y is either 3 or 1. Well, y wasn't the original variable in the problem. It was u. So now I'll back substitute. Instead of y equals 3, I'll say u squared plus u. U squared plus 2u equals 3. Instead of y equals 1, I'll say u squared plus 2u equals 1. So now it's like I had a little quadratic inside my quadratic like. Okay, u squared plus 2u minus 1. Okay, so I have two other little quadratics I have to solve. I think this factors u plus 3, u minus 1. That'll give me u squared plus 2u minus 3. Yep, and this one, there's no way this is going to factor. Okay, because of the minus here. So I guess I'll have to use the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's -2 plus or minus 4 plus 4 is 8. So I have 2 plus or minus 2 root 2. That's a lot of 2's. Take 2 into each of these, and we get 1 plus or minus the square root of 2. Those are two of our answers. Our other two answers are -3 or 1. So I have -3, 1, 1 plus square root of 2, 1 minus square root of 2. Those are our four answers, okay, to that quadratic like. All right, so those are kind of strange. Here's a different type of miscellaneous problem. Okay, this is a miscellaneous problem in that it has square roots in it. I don't think this is as big a deal as that first one. When I have the square root of something, to undo it, I square the entire side. Okay, this gives me x minus 1 equals 49, so x is 50. Always check square roots to make sure you don't get a negative under the square root. If I put 50 back in here, 50 minus 1 is 49. The square root of 49 is 7. I'm convinced. The difference with this next one, of course, is that I just have to remember sometimes people, they don't square the whole side. They just square each little piece. You have to square this entire side. So I get x minus 1 equals x minus 7 times x minus 7. Most people will just write x squared minus 49 or x squared plus 49. You have to square the entire side, which gives you x squared minus 14x plus 49. Okay? Now I have a quadratic. I need to get it equal to 0. So I'm going to subtract the x. I'm going to add the 1. I'm going to hope it factors, but if it doesn't, I will use the quadratic formula, so it's not a big deal either way. Once I get a quadratic, I know I can get an answer. 50 is 25 times 2. That's not going to do it. Oh, 10 times 5 would do it. If they're both minus, right? X squared minus 15x plus 50. So that means x is either 10 or 5. Great, let's check them out and see if they work. My original equation was square root of x minus 1 equals x minus 7. When I put 10 in, I get 10 minus 1 is 9, square root of 9 is 3. When I put 10 in here, 10 minus 7 is 3. Great, the left side does equal the right side when I replace x with 10. Let's try it with 5. 5 minus 1 is 4. Square root of 4 is 2. 5 minus 7 is negative 2. Nope. 5 was an extraneous solution. I thought it was going to work because algebraically it worked out. But when I square both sides, I'm losing the fact that you can't have a negative underneath the square root anymore. So sometimes you get these extra answers. They're called extraneous solutions. The only answer to this one was 10. Okay. This is no different. Squaring both sides. Okay. This is why I didn't really give you notes. It's a kind of a waste of paper to run off like just a problem like that. You can jot that problem down on your notebook paper, maybe pause me and try to solve it yourself, and then come back and see if you solved it correctly. When I square both sides, I get x minus 1 equals x squared minus 6x plus 9. Remember, it's not just x squared minus 9 or x squared plus 9. It's x minus 3 times x minus 3. I want this to be equal to 0, so I'll subtract x from the negative 6x. I'll add 1 to the 9. Okay, these are nice that they all factor. X minus 5, x minus 2. So I get x is either 5 or 2. Again, I will check them. When I put 5 in, I get 5 minus 1 is 4. Square root of 4 is 2. When I put 5 in here, 5 minus 3 is 2. Great. So 5 works. When I put 2 in, 2 minus 1 is 1. Square root of 1 is 1. But 2 minus 3 is negative 1. That didn't work. The only answer is 5. Okay, now, whenever I have a square root, I do try to isolate that, so it's just by itself. A little strategy that might help. Before I even try this, I'm going to write square root of x. 1 minus 3 is negative 2 equals negative 2 plus x, and that's awkward to me as well. I'm going to rewrite that as x minus 2 instead of negative 2 plus x. Then when I square both sides, I get x equals x squared minus, what would that be, 4x plus 4. When I do, x minus 2 times x minus 2, x squared minus 4x plus 4. I'm going to subtract x so that I have this equal to 0. So I get x, 0 equals x squared. I subtracted x from the negative 4x. Let's come up here. That factors into x minus 4x minus 1. Okay, and I get x equals 4 or x equals 1. So I'll go back to the very original equation and stick 4 in and see how that works out. Square root of 4 is 2. 3 plus 2 is 5. If I put 4 in here, 1 plus 4 is 5. That's looking great. When I put 1 in, square root of 1 is 1. 3 plus 1 is 4. When I put 1 over in here, 1 plus 1 is 2. It just didn't work out. So 4 is my only answer. Again, here, let's not deal with denominators. Let's multiply both sides by 3 before we start solving this. And then when I square both sides, don't forget to square the 3 as well. We get 9x squared equals 2 minus 3x. We have a nice quadratic. We want to set it equal to 0. So I add 3x and subtract 2. Oh boy, I don't know if that's going to factor or not. B squared, let's just see what that is. B squared minus 4ac. B squared is 9 minus 4 times 9 times negative 2. That's 9 plus 72. Oh, that is going to factor. I get 81. Yeah. Let's try it. I guess it's 3x and 3x maybe. 2 and 1 would be, let's see, 9x squared plus 6x. Oh, so I'd want it to be minus 3x to give me the 3x in the middle. And once I saw that my b squared minus 4ac was a perfect square, I knew it would factor. So I have 3x minus 1 is 0, or 3x plus 2 is 0. So in this case, x would be, let's see, I add 1, divide by 3, 1/3, subtract 2, and then divide by 3. So my answers are 1/3 or negative 2/3. So let's try it. If I put 1/3 in, 3 times a third is 1. 2 minus 1 is 1. Square root of 1 is 1, so I have 1/3 equals a third. Great. Negative 2/3. Well, I can tell you right now that's not going to work, right? How am I going to take the square root of something and get a negative? Okay, so anyway, I can tell that's not going to work. Alrighty. Again, we need to isolate our square root. So I'm going to add the 2 over the square root of 9x plus 1 to the other side. And then when I square both sides, this becomes 1 over x squared. When I square this side, I get 4 over 9x plus 1. We've solved rational equations before. I'm just going to cross multiply if that's okay. 4x squared equals 9x plus 1. And then I have another quadratic to hopefully factor. Boy, I don't see how I'm going to get 9. Do you? 4x, x, 1 and 1. And with the 2x, that's not going to work. So I'm going to have to use the quadratic formula for that one. Okay. Since I only had 20 seconds, I did that quickly for you guys. Opposite of b is 9 plus or minus the square root of b squared minus 4 times a times c all over 2a. You get 9 plus or minus the square root of 105 over 8. Okay, and that's square root equations.